Good morning, students. So today we are going to discuss about colloids and their types. So colloids, we will be studying its definition and then how many types of colloids are there on the basis of different properties. Okay, so this all we are going to study. Now first of all, colloids. Colloid is a heterogeneous system in which one substance is dispersed as very fine particles in another substance. That substance which is dispersed is called dispersed phase, and in whichever substance it is dispersed, that is called dispersion medium. Just like if we prepare starch sol or colloidal sol of starch, then starch will be the substance which is dispersed. Okay, it will be like white powder, so that substance will be dispersed phase, and it will be dispersed in water, so water will be the dispersion medium. Okay, so colloid is such a heterogeneous system in which one substance is dispersed, which is called dispersed phase, and it is dispersed in another substance. That another substance is called dispersion medium. Okay, now what is the difference between solution and colloidal? So basically, just like we prepare solution, we are preparing colloid also, but there is difference in the particle size. In case of solution, the constituent particles are ions or small molecules, whereas in colloid the dispersed phase may consist of particles of macromolecules, okay, such as protein or synthetic polymer, or if it is not macromolecule, then it may be aggregation of a large number of molecules or atoms or ions, which will give rise to the larger molecule. So what we can say? We can say that in case of colloid, particle size is quite larger as compared to particle size in case of solution. Okay, so colloidal particles are larger than simple molecules but small enough to remain suspended. Their range of diameter is between 1 and 1000 nanometer. So how can we say that in case of colloid there are two phases, just like solute and solvent in solution, but particle size, that range is from 1 to 1000 nanometer. Okay, and if the particle size is less than 1 nanometer, then it comes out to be solution. Okay, now how can we classify? Colloids can be classified in three ways. First way is when we see the physical state of both the mediums. One is dispersed phase and another is dispersion medium, both the components in which state they are. On the basis of that, we can divide the colloids in different categories. Then what is the interactive force between dispersed phase and dispersion medium, how they attract each other? On the basis of that, we can divide. And then how the particles are present, which particles are present, to which category those particles belong. On the basis of that, we can divide our colloids in different types. Okay, so which particles we are talking about? We are talking about dispersed phase particles. Now you can see this picture, these all are colloids. Okay, these all are colloids. Now just like if you imagine paint which is used for painting our walls or windows and doors and this and that, so that is also a colloid. Okay, now first of all we will classify our colloids on the basis of physical state of dispersed phase and dispersion medium. Okay, so here there are so many categories. There are total 8 categories in which we can divide all the colloidal sols. Okay, so one thing which is to be remembered is a gas mixed with another gas forms a homogeneous mixture, and so it is not regarded as a colloidal system. So if we are mixing two gases, then it becomes a homogeneous mixture. And in our definition itself we said it is a heterogeneous system. Colloid is a heterogeneous system. So if we mix two gases, then we will not say that it is a colloid. Okay. Now first category, if both dispersed phase and dispersion medium are solids, then it is called solid sol. Okay, just like some colored glasses and gemstones, they are solid sols. If dispersed phase is solid, dispersion medium is liquid, then it is called sol. Okay. Now sol, for example, paints come into this category. If dispersed phase is solid and dispersion medium is gas, then it is called aerosol. Okay, aerosol, just like smoke is in this category. If dispersed phase is liquid and dispersion medium is solid, then we say it is a gel, just like jellies, you know jellies. So those all jellies are a type of colloid. Okay. If both are liquid, then it is called emulsion, just like milk is in the category of emulsion or butter is in the category of emulsion. Now if dispersed phase is in liquid state and dispersion medium is in gaseous state, then we say it is aerosol. So see, aerosol was here also and here also. So on which basis we are saying? If dispersion medium is gas, then it is called aerosol. Okay. If dispersion medium is solid, then we say, just like here and here, these two are solids, so we say it is solid sol. Okay. Now if dispersed phase is gas and dispersion medium is liquid, then it comes in the category of foam. Just like whipped cream is there, that is of the category of foam. Or froth flotation process we did earlier. So froth is a type of foam, it is a type of colloid. Okay. So these are the 8 categories on the basis of dispersed phase and dispersion medium. Now on the basis of interaction between dispersed phase and dispersion medium, which type of attractive forces are there, on the basis of that we can divide on the 2 categories. One category is lyophilic and another category is lyophobic. Okay. So lyophilic are also called solvent attracting. Philic means attracting, phobic means heating. Okay. So lyo means liquid. So lyophilic, from the name itself we will say lyo means liquid or solvent, philic means attracting. Okay. And reverse is the case of phobic. Phobic means hitting or repelling. So on the basis of attractive forces we can say that we can divide our sols into categories, lyophilic sols and lyophobic sols. Now in case water is the dispersion medium, then we can say this is hydrophilic and this is hydrophobic. Okay. When solvent is our water, then we will say water is represented by hydro. So hydro word means water. So if water is the solvent, then we will say it is hydrophilic or hydrophobic. Okay. Now first of all let us discuss lyophilic colloids. Now lyophilic word means liquid loving. Colloidal sols directly formed by mixing substances like gum, gelatin, starch, rubber, etc. with a suitable liquid, they are called lyophilic sols. So what we can say? We can say that lyophilic colloids are formed simply by mixing our dispersed phase in dispersion medium, because they are liquid loving. The dispersed phase has interaction for dispersion medium, so they are just obtained by simply mixing the two. Okay. Now an important characteristic of these sols is that if the dispersion medium is separated from the dispersed phase, the sol can be reconstituted by simply remixing with the dispersion medium. Means if in case we are having certain lyophilic sol, then if because of evaporation it has evaporated, its dispersion medium particles have been evaporated, then what will happen? Then we can again put the dispersion medium and we can obtain the sol again. Okay, so what we can say? We can say that these can be reversible. These are reversible nature. Okay, so that is why these sols are called reversible sols. Now see here, you can see this is a gel sort of thing coming out. Okay, it is just like gum tube. You are using gum for sticking photographs and all. So that gum is a lyophilic colloid. That gum is example of lyophilic colloid. Okay, so few more properties of lyophilic colloids are they are quite stable and they cannot be easily coagulated. What is coagulation? This is a property that if dispersed phase can be made to settle down, then it is called coagulation. Okay, so this we are going to discuss in detail after next session. Okay, so lyophilic sols are these, and these were the properties of lyophilic sols. Now lyophobic sols or lyophobic colloids. Now similarly, the word lyophobic means liquid heating. Okay, liquid heating. So substances like metals, then they are when mixed simply with dispersion medium, they do not form colloidal sol. Now see, suppose I have to prepare gold sol, then what will I do? Then that cannot be prepared by simply mixing the two. Okay, so we will say that it is lyophobic category. Okay, now these sols, if they are formed, then they can be readily precipitated or coagulated on the addition of certain amount of electrolyte or by heating or by shaking, and hence they are not stable. So one more difference from lyophilic colloids is that these sols are not stable. Why they are not stable? Because they undergo coagulation easily. Okay, now once they have been precipitated or coagulated, then they do not give back the colloidal sol by simple addition of dispersion medium. Okay, just like there what we said that in case evaporation has reduced the content of dispersion medium, then we can simply add dispersion medium and it will again give the colloidal sol. But in this case, if it has been coagulated, precipitated, then we cannot simply add dispersion medium and obtain the lyophobic sol. It is not possible. So what do we say? We say that these colloids are irreversible sols. Okay, now since these sols are irreversible, they do not have interaction for dispersion medium, so what is required for their stability? They require some compound which must be added in them so that it is stable. Okay, now that particular substance which is required, what it does? That substance binds the dispersed phase and dispersion medium particles, and when it binds, then it makes it stable. Okay, then it is feasible and then it stays. Okay, now here in this diagram you can see that here you can see we are mixing the dispersed phase in dispersion medium, but they are forming different layers, so there is no interaction between the dispersed phase and dispersion medium. So for making a particular similar type of mixture, what is required? Some stabilizing agent is required, okay, which will bind both the molecules, and then a particular mixture will be obtained and there will be lyophobic colloid formation. Okay, now let us discuss classification based on type of particles of the dispersed phase. Okay, now see, type of particles of dispersed phase, on the basis of this we can divide our colloidal sols in three categories: multimolecular colloids, macromolecular colloids, and associated colloids. Okay, so these three categories are there depending upon the type of particles of the dispersed phase. Okay, multimolecular, macromolecular and associated colloids. One more name is there with associated colloids, that name is called miscellaneous. So miscellany is associated colloid. Now first of all, multimolecular colloid. Okay, now see, on dissolution, a large number of atoms or smaller molecules of a substance, they aggregate together to form species having size in the colloidal range. The species thus formed are called multimolecular colloids. Okay, now see, from the name itself what we will come to know, multi means more than one, molecular means molecules. So in this colloid, so many molecules will come together and they will form a bigger molecule. That bigger molecule will have the dimensions of colloidal range. So if this happens in a particular colloid, then we will say that this colloid is multimolecular colloid. Okay, for example, if we talk about gold sol, so what happens, size of gold particles is very small, that is not of the colloidal range. So what happens, a large number of gold particles, they come together, they aggregate together and then they form a bigger molecule, and that bigger molecule is of the dimensions of colloidal range, and so we say that gold sol is multimolecular colloid. Okay, now similarly sulphur sol is also multimolecular colloid. Okay, now see, in this case these bottles are of gold sol. Okay, now here they are of different concentrations, so these are gold sols and these are examples of multimolecular colloids. Now we come to macromolecular colloids. Okay, now see, macromolecules in suitable solvents form solutions in which size of the macromolecules may be in the colloidal range. Such systems are called macromolecular colloids. Okay, now see, in simple words what we can say, that if in a colloid the dispersed phase particles are of macromolecules, then such colloid is called macromolecular colloid. So simple definition is, the colloids in which dispersed phase particles are macromolecules, they are called macromolecular colloids. For example, if we take starch, cellulose, proteins or enzymes, then these particles, these molecules, they are called macromolecules. Okay, now if we take these as dispersed phase and then in the suitable dispersion medium we mix them, then we will say that those colloids formed are macromolecular colloids. Okay, now these were naturally existing macromolecules, and there are man-made macromolecules also, like polythene, nylon, polystyrene, synthetic rubber. These all are man-made, or we can say they are not natural, they are synthetic macromolecules. So see, this you can see the consistency. If this type of consistency is there, this type of thickness is there, then it is a type of colloid. Okay, here what we have taken, we have taken certain colloid, and then you can compare it with gum powder also, that gum which you are using in your daily life, in your daily routine. So that is also having that much density, that much thickness. So this is just to show that colloids have this type of texture. Okay, now let us come to third category. Third category is associated colloids or miscellaneous. Okay, now here it is very interesting. There are some substances which at low concentrations behave as normal electrolyte, but at higher concentrations they exhibit colloidal behavior. Okay, now see, if there is a substance which we have taken in low concentration, then at low concentration what will happen, it will appear or it will act as a electrolyte, simple electrolyte. What is simple electrolyte? That it is going to conduct the electricity in its aqueous form or in its molten state. But when we take its aqueous solution and we increase the concentration, then it behaves like colloidal. Why it behaves like colloidal? Because colloidal, what is the main property of colloid? They are having particle size in the range 1 to 1000 nanometer. So what happens here? Those particles which are dispersed phase, they will come together and they will form bigger molecules. That aggregation, that aggregated form is called mislees. Okay. Now since so many molecules have been associated to give colloidal dimensional size, so this is also known as associated colloids. Okay. Now every time it will not be formed, this mislees will not be formed. The formation of mislees takes place only above a particular temperature called Kraft temperature. Okay. It requires some temperature also. If temperature is very low, then also mislees will not be formed. So certain particular temperature is required, which is called Kraft temperature, and above a particular concentration, some minimum concentration is required. If we are giving high temperature but concentration is very low, then also there will not be formation of mislees. So that minimum concentration which must be there is known as critical mislees concentration, CMC. Okay. So on dilution, these colloids revert back to individual ions. So if we again dilute, then it means we have reduced the concentration. Then again those mislees will break down and again it will behave as normal electrolyte. Okay. So soap is an example of associated colloid. Soap and detergent, they are the best example of associated colloids. And CMC is 10 raised to power minus 4 to 10 raised to power minus 3 mole per liter. Okay. These colloids have both lyophobic and lyophilic parts. Okay. There is presence of lyophobic part also, lyophilic part is also present. Okay. Now let us discuss mislees. Okay. Now mechanism of mislees formation. Okay. Now see, if we talk about soap, then soap is sodium or potassium salt of higher fatty acids. And in general, how we can represent RCOO Na, where positive, when it will ionize, then it will form RCOO negative ion and Na positive ion. So we have shown this here itself, RCOO negative, Na positive. Now for example, R is alkyl group. For example, this alkyl group has 17 carbons, then its formula will be CH3 CH2 whole 16 COO negative Na positive. Okay. This is the formula of sodium stearate, or this is sodium stearate. It is one of the soap. Okay. Now when dissolved in water, when we dissolve it in water, then it will dissociate to form these ions, just like we said property of electrolyte. So they will behave as electrolyte. Okay. Now this ion consists of two parts. Okay. There is long hydrocarbon chain R, also called non-polar tail. Okay. Non-polar means it is hydrophobic, it is not attracted towards water, and a polar group COO negative, which is called polar ionic head, and it is hydrophilic in nature, means it is attracted towards water. Okay. Now RCOO negative ions are therefore present on the surface with their COO negative group in water, and the hydrocarbon chains are staying away from it and remain at the surface. So see, since it has, this molecule has water loving end also and water heating end also. So water loving end will be attached with water and water heating end will be away from water. So water heating end, that is this non-polar end or water repelling end or non-polar tail, this end will be on the surface. Okay, means it is trying to be away from the water, but at critical Missli concentration. Now when CMC is given, in normal situation we said this, but at critical Missli concentration, the anions are pulled into the bulk of the solution and aggregate to form a spherical shape with their hydrocarbon chains pointing towards the center of the sphere, with COO negative part remaining outward on the surface of the sphere. An aggregate thus formed is known as ionic Missli. So what we are saying here, we are saying that when CMC is achieved, when we have increased the concentration, then what happens? Then they are attracted to form a bigger molecule. That bigger molecule is called Missli. Okay. Now how it functions, that we are going to see it now. Okay, now see, this is sodium stearate molecule. So we have arranged this R group, this is R, this is COO, and this is Na. Okay. Now see, this R group, this end is called non-polar end, because there is no charge in this, and this end forms polar end. Okay. Now this is the molecule, this is molecule, when it ionizes it gives RCOO negative ion. Okay. So this negative ion has this hydrophilic end which is attracted towards water, and this is long chain of hydrocarbon which is heating from water, which is not attracted, which is called non-polar or hydrophobic end. Okay. Now this thing can be represented like this. Okay. Now this zigzag chain represents the long chain of carbon atoms. Okay. Now this way our soap molecule exists. Okay. Now if we talk about detergents, then what happens? For example, sodium lauryl sulfate, then its formula will be like this. In place of COO negative, there will be SO4 negative. Okay. Then just like here it is COO negative, which is hydrophilic end, this will become the hydrophilic end. Sulfate ion SO4 negative, this will become the hydrophilic end, and the mechanism will be same, just like in case of Missli. Similar way they will form Misslis. Okay. Now see, here you can see, if we have taken our solution of soap in water, then how it will appear. Now see, in this diagram, arrangement of stearate ions on the surface of water at low concentration of soap. When concentration of soap is low, then it is going to behave as normal electrolyte. So when it is behaving as normal electrolyte, then hydrophobic end will be away from the water and hydrophilic end will be attached with the water. Okay. But when we will increase the concentration, we will bring it to the CMC, critical Missli concentration, then what will happen? Then these stearate ions, they will be pulled inside, and inside they will form ionic Missli. Now how they will form? Now see, this is one molecule just like this. Okay. Now these were pulled inside and they came together. Now these many molecules have come together and this bigger molecule is formed. This bigger molecule is called Missli or ionic Missli, and this is in the colloidal range now. Okay. So this is called Missli. Now how it cleans the clothes, or how dirt is removed, that also we are going to discuss. Now see, here in this diagram, here you can see grease on cloth. Now see, when we are talking about the cleaning action, then our action is to remove dirt from the clothes. Now dirt is the mixture of oil and dust. Okay, so main thing is how to remove oil. So here oil or grease, one and same thing. Grease means that particular oil. Okay, now in this diagram we have just shown the grease on cloth. Now in B diagram we have shown stearate ions arranging around the grease droplet. So when we dip our dirty cloth in soap solution, then what happens? Then this type is formed. So many molecules will get attached with the grease or with the oil drop. Okay, and third diagram is grease droplet surrounded by stearate ions. Means what happens? Now so many molecules surround it. Okay, then what happens? Then we are able to see here negative end is towards outside. Okay, now when so many molecules will get attached with the oil drop or with the grease drop, then the end which is outside, that end will repel each other. Why it will repel each other? Because of similar sizes, similar charges. So because of similar charges, they will repel each other, and what will be the result? Since they are in touch with the grease, this is grease. Okay, they are in touch with the oil drop or grease. So because of repulsive force, this repulsive force will increase when we will agitate the cloth. So when we agitate the cloth, because while washing what we do, we apply the soap solution, we apply soap, and then we rub it properly. Okay, so that rubbing or beating with some stick or like that, so that causes this repulsive force to increase. Okay, so this repulsive force when increases, then these all molecules move away from each other. When they move away from each other, then what they do? They take a micro portion of this oil or grease droplet along with themselves, and in this way what happens? That grease or oil drop that breaks down and that is carried away by different molecules, and in this way that oil or grease gets removed from the cloth. Okay, so this is the mechanism of our washing. Okay, so how this dirt is removed, this is the mechanism. Okay, now see, let us revise this. A mistletoe consists of a hydrophobic hydrocarbon like central core. The cleaning action of soap is due to the fact that soap molecules form mistletoe around the oil droplet in such a way that hydrophobic part of the stearate ion is in the oil droplet and hydrophilic part projects outside the grease droplet like the bristles. Okay, since the polar groups can interact with water, the oil droplet surrounded by the stearate ion is now pulled in water and removed from the dirty surface. Thus soap helps in emulsification and washing away of oils and fat. Negatively charged sheath around the globules prevents them from coming together and forming aggregates. So this is in the same way, in simple way I told you that how to explain it. How can we explain it? We will just say that the molecules of soap, they get attached with the oil droplet. That oil droplet is also non-polar in nature. So non-polar end gets attached with the oil droplet and they form mistletoe. When mistletoe is formed, then similar charged ends are on the outside. Those similar charged ends repel each other, and because of this repulsion, the oil drop breaks and each molecule of soap carries away along with it the smallest portion of the grease, and in this way that oil droplet gets removed from the cloth. Okay, now Whatever we have discussed today, on the basis of that you have to solve these home assignments. Okay, thank you.